In this lesson, all we're going to do is look at some questions. And the questions deal with atomic structure, and they're actually pretty simple questions. What I'll do is I'll ask you a question. Usually it will involve a diagram, and you answer the question, and then we'll go over it together. So let's go ahead and look at the first question. And the first question is, in what period of the periodic table would this element be located? Well, you see a diagram of an atom. It's got protons, neutrons, and electrons, energy levels, and electrons in those energy levels. So you should be able to look at this diagram and very quickly tell what period of the periodic table this element would be located. So go ahead, pause the video, answer the question, then start it up again and we'll go over the question together. So go ahead, pause the video now. Well, if you're back, let's take a look at the answer. The answer is, well, because the highest energy level that contains at least one electron is the third energy level, it would be period 3. The period number is equal to the number of the highest energy level that contains at least one electron. That's for all atoms. An atom, for instance, in the 4th period is going to have electrons in its highest energy level, the 4th level, and so on. Let's take a look at another question. Question 2, 3, and 4 deal with the diagram that you see here. And again, we have an atom. It has protons, neutrons, electrons, energy levels. Well, go ahead and see if you can answer these 3 questions. So pause the video, answer the questions, come back, and we'll go over them. So go ahead, pause the video now. Well, if you're back, let's go ahead and answer the questions. What is the atomic number of this element? It's pretty easy to figure. All you have to do is count the protons. The atomic number is equal to the number of protons, which in this case is 4. Well, question 3. Name the element that this atom diagram represents. Well, you're looking for an atom that has 4 protons. You already know that. So it's going to be atomic number 4. And it's going to be beryllium. The name of the element depends on the number of protons, which equals, of course, the atomic number. And the last question here, what is the mass number of this atom? Well, the mass number in this case is 7. The mass number for any atom is equal to the total number of mass particles, that means protons and neutrons, that are found in the nucleus. In the nucleus of this atom, there are 7 particles. There are 4 protons, 3 electrons. So let's go ahead and look at the next question. Now the next question says, in which periodic table group, not period but group now, would the atom shown here be found? So go ahead, pause the video, answer the question, and then come back and we'll go over it again. Pause the video now. Well, if you're back, let's go ahead and answer the question. Hopefully you got the same answer I did. This atom should be in group 17, or in older periodic tables listed as group 7A, because it has 7 valence electrons. Like all elements in group 17, it is a halogen. Because of this, it's extremely chemically reactive. Why? Because it only needs 1 more valence electron to get a stable octet, like its nearest noble gas neighbor, neon. And you can see in this diagram that 1 more electron would make that stable octet in that highest energy level, that valence level. So this is in group 17. Remember, the number of valence electrons tells you what group the atom is in. And valence electrons are only the highest energy level electrons. The electrons located in that highest energy level. Here, it's 7. Next question. In which periodic table group would the atom shown here be located? Well, we have 10 protons, 9 neutrons. How is this going to tell you what periodic table group this is going to be in? Go ahead and pause the video, answer the question, start the video back up again, and we'll go over it. Go ahead and pause the video now. Well, if you're back, Let's go ahead and answer the question. And the answer is, this atom should be in group 18, or 8A if it's an old periodic table. And the reason is because it has 8 valence electrons. Remember, it's the number of valence electrons that's going to tell you what group the atom is in. This is a noble gas. Like all noble gases except for helium, it has 8 valence electrons, a stable octet. And because of this, it is chemically stable. And normally, it won't react with any other element under normal circumstances. All right, let's go ahead and answer the next question. Determine the oxidation number of this atom. So go ahead, pause the video, answer the question, start it back up again, and we'll go over it together. Pause the video now. Okay, if you're back, determine the oxidation number of this atom, and if you said that the oxidation number was 0, you were right. This atom has an oxidation number of 0. It has a full complement of electrons, of valence electrons, in the outer or highest energy shell. It is a noble gas. All right, try this one. Determine the number of electrons this atom should have. Go ahead, pause the video, answer the question. When you got it, start the video back up and we'll go over it together. Pause the video now. All right, if you're back, let's go ahead and answer it. And you know something? Number of electrons in the ground state is going to be equal to the number of protons. Why? Because in the ground state, the atom is going to be electrically neutral. And in that case, it has to have the same number of electrons as protons. So there's your answer. This atom should have a total of 10 electrons. In the ground or uncharged state, an atom will have the same number of electrons as it has protons, thus making the atom electrically neutral. And there are the questions. Hopefully you got every single one of them right, and I'll give you an A. So go ahead, and you've earned bragging rights. Thanks for watching.